rack at all. Then you can put the Black Joe on, and like I said, normally on a corner, you're gonna have at least one sheet of plywood to lock in that corner. Cool? So that's a wind brace. Sometimes, old school, they'll do a burring strip, but they'll notch all the studs for a burring strip. You can see that's kind of really old school, but that's another way of doing it. Just like we saw the ribbon, the little ledger for the joists in the balloon framing, be the same thing. He's going to notch it in. See, he's going to notch it in, but it's just going to be a piece done exactly like that, but on the diagonal. So he's going to run that brace all the way down like that. Cool? So out of a normal wall, we've got what? Oh, where's my drawing? Have you guys even looked at your papers yet? Oh, you can see it on the PowerPoint, eh? So what do we call this on the floor? Bottom plate. Wall's super easy. Bottom plate, top plate, second top plate. In French, it's lisse, sablière, deuxième sablière en haut.
Sablière.
Sablière. You tell me, I don't know. Your department.
Yeah, but sablière.
Okay, so we've got our plates, bottom or sole plate. All right, so we've got a bottom plate. Then we've got what's running up vertically. Studs. And then we've got what up top? Top plate. Cool? Now we've got an opening. We've got a rough opening. What do we have for our rough opening right here? Miguel? King stud. Okay? You got your kings right here. They're the exact same thing as a normal stud. The only reason we call them kings is what do we have here? Lintel. We got our header. Now we got to support that header. We got to transfer all that load. So how are we going to do that? Jack stud. Right down like that. In Quebec, down below, sometimes they'll put a piece of wood along like this.
Kicker?
Kicker? Top plate? I don't even know what you call it. Doesn't really say. Why do we not go all the way in like that? Why would we not frame it like that?
Do you not know?
The only reason we do it like that is because it's just giving another little 30 seconds for that mushing to happen. Yeah. You want to avoid anytime you're going like this with anything, it's going to settle. So if you do 3 floors, it's not much, you know, a 16th, an 8th, but that's a lot over time. And you add it all up, that's just one little area. You're building 3 floors, you know, 16th, 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 you're at 3 16ths, plus what all the joists are doing, plus everything else. Your whole building's settling a good 1/4 inch, 1/2 inch sometimes. So to avoid that, they're like, no, you're going to go right to the bottom of the header. You're going to support that as tight as possible. You don't have to put any less bacon in the sandwich, you know what I mean? Like less layers to mush around. Well, you know what I mean? Like you're adding all these things. You got a floor joist, you got walls, you got bottom plates, you got studs, you got top plates, you got headers, you know what I mean? Every time you add something in that sandwich, it's more chance of all that stuff to settle and compress. So less bacon in the sandwich, Michael. All right? So we got headers, we've got jacks, we've got kings. Guys, now for our window, what do we have here? Rough silk. Cool. Now what do we got here? Cripple studs. Cool. Rough silk. Cripple stud. Sometimes, depending on how you're going to build a wall, you might have a few up here. You might have another plate like that, and then more cripplers up here. You know what I mean?
Right.
Sorry about the drawing, guys. It's pretty rough, but so these will be little cripplers or bonhommes in French. Normally on the job, when you're working, they're only going to call them bonhommes. Even on an English crew, I think we call them bonhommes in Quebec too. So there you can have little bonhommes. I kid you not, it's little bonhommes, man. So there's your basic wall, right? We're good with that. Jack studs, lintels, cripple studs, king studs, rough-in, and on-center studs. Why do we call them on-center studs?
They're just regular studs, right?
They're just regular studs. Whoa, what are we going to frame that at normally?
16.
16. Normal exterior wall, 16 inch. How come we frame that at 16 inch? Michael?
What?
Why do we frame on 16 inch on center?
Because plywood.
Nice. What do we use for plywood?
4 feet thick.
4 by 8, 4 by 9, 4 feet is pretty much what we're using. Because of that, it's 16 inch on center. Now, since we use 16 inch on center, all our other products are built for 16 on center. That means your wool is going to be 15 and a half. It fits right in that cabinet. Your space in between your studs, nice 14 and a half. Wool fits in with compression. All our products follow that. Now, what's the problem with 16 inch on center? Insulation. Okay, if we had it our way, we have a structurally, you could fill your wall completely with wood, right? That's going to be the strongest wall possible. I guess it would be 0 inch on center, right? So what's the problem with that? Why don't we build our walls solid?
No insulation.
No insulation. All right. So everywhere you have a stud, what happens?
Solid wall.
No insulation. Almost 0 through a piece of wood. You guys have done insulation? Guillaume?
Yeah.
A little bit, halfway through? So you can have transfer of cold, right? Through the header, through the studs, through all the wood. Here you're insulated. There you're fine. In between, you can stuff a nice bat in there, and you need R20 out of that. On the woodwork, on all the studs, it's going right in the building. So, ideally, structurally, we build a solid wall. It's going to be the strongest goddamn wall and the heaviest wall you're ever going to see. But we can't do that. It's a little expensive and a little ridiculous. So we go 16 inch on center. What other centers could we use?
24.
We could go 24. Then you're going to do what? You've got less wood in your wall. You're going to have way more wool in your wall. You're going to have a warmer wall. Okay? But what's the negative of that?
Not so strong.
Not as strong. Okay? So we could go 19.2 on center. We could go 24 inch on center. We could go 16 inch on center. We could go a foot on center. It's whatever we want to do. Modern building practices, you want to keep that as farther apart as possible to get more wood and wool in your wall, but you run into problems where your building's not strong enough. So again, your wall's made to support the next floor up. That's why we have headers, because if you have a floor joist or a truss sitting right here, where's that being transferred down to? Onto the header, onto the lintel, and that's going to transfer down the jack all the way down to the foundation.
What if in the bottom floor you go on 16 center and on top you go 24 center? Can you do that?
Yeah, it's a little weird. Okay, ideally, what you would do, okay? This is my dream house, right? You'd have your floor, and you would build your floor joist like this. I took out the rim joist, okay? This is like a cut view of it, right? Let's say you go 16 inch on center with your, go 16 inch on center with your floor joist, right? Then we're gonna put plywood on that, and then we're gonna build a wall. We build our wall, and when we calculate where we're putting our studs in that wall, we're gonna go in the same centers as the floor. So each of your stud is gonna come up like that, come up like that. Okay, there's our first floor. Now we're gonna drop our trusses on. What's the best place to put a truss then? We're going to go our trusses in line with that. See what I mean? So what's happening now?
all the way.
What's all that snow load doing? It's going through our truss, onto our stud, onto our joist, right down to the foundation, right? So that's the ideal situation, and we honestly try and do it. Another real bonus for that is utilities. You think the HVAC guy's going to be happy? He's going to be super happy. So he's got to run ductwork through the floor, and he's got to run up the wall. It all lines up. Look, he's going to put an elbow here, and he's going to run his ductwork right up the wall. If we did the opposite, if let's say his floor joist is here, right, and what's the ductwork guy's going to do? What's the plumber going to do? So it's great for utilities when everything lines up like that, but it's rare that it does. We try and try, but ideally, that's the situation you want. Kind of a mess, but this is the situation when you want that to transfer all the way down to the foundation.
But why doesn't it line up usually?
Because we will frame our floor maybe with poutrelles, and it'll be on 24s or 19.2. You guys know about 19.2, eh? No? If you look at your tape, you see the little diamond there? Okay? So that's your 19.2. So sometimes to save a bit of money, to save a poutrelle, if you're doing a big long floor, if you're building 50 houses and you go 19.2 instead of 16, well, every job you get an extra poutrelle or two or whatever. Poutrelle is going to be pretty expensive. So that's another reason to use it. It'll be marked in your plan, and there are your centers. All right, so let's say you frame your floor with 19.2, and what do you do with your walls? You're going to frame your walls with 16 so it doesn't line up. Okay, it's the modern construction method. It works, it's fine, but ideally, if we could line everything up like that, when we speak of transfer of load in ideal situations to transfer all that snow load right down, you'd be building like that. It's way better for utilities, it's way better for the strength of the house. But it rarely works out like that. Cool? Studs, we looked at studs. Lintels. Okay, what do we make lintels out of?
2 by 6 or 2 by 8?
2 by 6, 2 by 8,
2 by 2 times 14?
2 by 6.
2 6.
2 6.
2 by 6. Grab 2 by 6. Normally on a job, 2 by 10.
2 by 10?
2 by 10. It depends on the opening. I'm talking a normal opening. As openings get bigger and bigger, you know, obviously there's a big difference from framing a doorway like that, a 36-inch door, to putting in a window like that. Okay? So what's the difference? Look at that span. In modern buildings, our windows are getting bigger and bigger and bigger. Nobody wants walls anymore, we want it all window. So to get that, we get into header material. Now, 2 by 10 is great for a doorway, 36-inch opening, no problem. Take 2 by 10s, shoot them together. Usually go flush on the outside, so you have a missing space on the inside. 1.5 inches plus 1.5 inches, what? 3 inches. What's a 2 by 6? Oh, how wide is a 2 by 6?
5.5.
5.5. So what do we got? What do we have a problem there? Right? You can have a cut view of your wall. You have your top plate. You have your 2 by 6. And you have 1, 2, 2 by 10s nailed together. What do we got there? This is your header. We need 5.5. What I'm saying is we're not flush on the inside. You have 3 inches going into a 5.5 space. Know what I mean? You know why we have 3 inches? We have two 2 by 10s nailed together. That's our header. Okay, now we have a stud going like that. Okay, and here's your jack. I'm doing like a cut view. Okay, so what's this space here?
What's the...
It's just empty space. What that enables us to do is put some insulation in there. Again, you don't want to do a full header, okay? Because it's overkill. If you're doing a 4-foot door, all you need is two 2 by 10s. We'll go over calculating all that. But the reason you use only two 2 by 10s, we're talking exterior wall here. What's getting in?
Air.
Air, cold. Cold, transfer of cold. That wood's not insulating. So if you have a space there, you can slip in a piece of rigid insulation. Cool? Now, when we get into bigger spans, we get into more engineered products. Because we're at 3 inches with our two 2 by 10s. What if I told you we could use an LVL and have a true 2 inch, and that's strong enough, right? We learned that in flooring, how strong poutrelles are. how strong engineered beams are. So when we talk about LVLs, PSLs, and glue lams, do you remember all that? No? No? Yes? I'm getting blank stares? Yeah?
Yeah, but not PSL.
Okay, well, PSL is a parallel strand lumber. It's all pretty much the same thing. So here you got one is what? Built up lintel with a 2x4, 2x6 laid flat on the bottom. Okay? Number 2 is a built up lintel with a 1/2 inch spacer sandwiched in between. That's normally for 2x4 construction because you have a stud that's 3.5, right? Then you're going to build you're going to sandwich two 2x10s, a 2-ply header. Okay, so now you're missing a 1/2 inch. So what they used to do back in the day when we built with 2x4s, you would add a layer of 1/2 inch plywood in there, so your header is the exact same width as your 2x4. So it's nice and flush on the outside, and it's nice and flush on the inside. Now that we build with 2x6s, we don't want to build 5.5 inches of header in there because 1, it's expensive and it's time consuming. 2 is because the transfer of cold, you got all that wood, you have no insulation in there. So now with modern methods, we're going more towards 3 is a built-up lintel for a 6-inch wall. So see that? Solid wood, not a piece of insulation in there. Okay? Number 4 is a lintel of solid sawn lumber. That's a bit mad. That's just a huge chunk of wood. All right? Now we get into 5. Glue lam beams are often used for lintels. What's the reason we use these? Super strong, and it's probably thinner than using 2x10s. So the thinner we get with the wood, the more insulation we can get in there. And then we get into, that's a glue lam and a built-up lintel of laminated veneer lumber. So here we have an LVL, and here we have a PSL, a parallel, oh my God, parallel. Thank you. Parallel strand lumber makes excellent lintels. The reason we're using all these engineered products, LSL is used for light duty lintels, and energy efficient lintel with rigid foam insulation. So there he's got the insulation built into his header. Alright? So the reason we're looking at all these is as our spans get bigger. So if we had to do our span for this window, you're looking at it, you're like, oh man, the only way this is going to fit, because you're checking your code book, the only way this is going to work properly is if we go 3 2x10s. Right? So what's that? It's expensive. Okay, it's going to do the job. It's strong enough. It's expensive. You got to build it. Okay, that means Jesse and Michael have to nail this thing together and PL it together. Or you can go a true 2-inch, right? Instead of 4.5 inches, you can go a true 2-inch of engineered product for your header, and it does the same thing. And then you got inches of insulation. You can get some rigid insulation in there. Cool? You know why? Like I keep saying, you guys, modern construction, we're losing beams, where our spans get farther and farther, right? When we looked at using a 2x8 for a floor joist instead of a poutrelle, what's that do? We're getting farther. You can go farther till you have to sit on a beam, or farther till you have to sit on a foundation. Same thing with using engineered products for headers. You can go farther. There, a 2x10, no problem. A header for this guy is going to be at least 3-ply. So to hell with that, let's buy an LVL. Probably cost maybe a little more, but it's one cut. These guys don't have to assemble it, and you can get some R value on the back end of your header.
But what do they do about the log houses? You know when they have like chalets, it's only like.
That's just solid walls.
But
That's just
what about insulation?
no. You almost build another wall on the inside. A log cabin is not a warm thing. It'll hold heat, but it's not an insulated
When
wall.
you're inside, don't you see the wood?
Well, it's up to you. Yeah. Sometimes they'll cheat it and cut them in half and hide an insulated wall on the inside. But your typical old school log cabin is fire up the wood stove and and restock it in the middle of the night too. So that's another thing. Okay, so I just want you to realize that headers, especially on modern sites, headers are not always just a 2x10 or a 2x12 or a 2x6 or a 2x8. Sometimes you're going to get into LVLs, into PSLs, into glue lam. It's a beam is what it is, right? So if we have a beam that's holding up our floor, spanning this room, what's a header doing? It's the same thing. So you can have roof trusses sitting all on that header. You don't want it to bow. You don't want it to bow and touch the window, right? So that's why we end up using modern products like this, which are amazing, by the way. Eh? Like when you start building a house, you'll love all these things. Like to pull out an LVL, like I said, it's one measurement. Michael's gonna go, and you're putting it on. Compared to, when you build a beam, of course all our wood's crooked, right? So you got to do a 3-ply beam. You gotta put PL on it. You gotta tack it. You gotta fight the 2 warps to get it nice and flush. You guys dealt with it down there. You're fighting with crooked wood. Whereas an engineered product like a steel stud is good. It's nice and straight. Nice wood to use. It always works. You can nail right into it. You can put a hanger right into it. So very often you'll do renovations and you can go up in the ceiling, put a beam, and hang the ceiling joists on it instead of having an exposed beam in the kitchen. It's all hidden up in the ceiling. Amazing products. Hangers, PL, LVLs, PSLs, glue lams. You'll get used to all that on site. They're amazing products. They make our job a whole lot easier. And with that, we're able to put in big windows and do big spans, which is very cool for engineering and architectural point of view. Okay, so we've got terminology. We have an idea of what these things are called, right? We get the rough sill, jack, lintels, top plates, bottom plates, king stud, rough openings. We're all good with that. Here's some pictures. Here's a glue lam beam. Header. You guys can see that? Am I in your way? So you see how it works on a job? So instead of having a massive, it is still a massive chunk of wood, but you can see what it's holding up. So you got the whole other floor sitting on top of that, hence we need a header. Even over here, there's nothing really sitting there, but it's a nice supporting wall that they've built. Here is a PSL header. You can see exactly how it works. You got all your bun-ums here, and that thing's transferring all that load from the second floor is coming down. It's transferring into onto the jack stud and running all the way down. Here they've got kind of almost like a truss system to build up for headers. Same sort of thing.
That's when you have space for that, right?
If you have space for it, yeah. So there's your rough sills, your jack studs, your trimmers. Some people call them trimmers, and your corner posts. Your again cripple, lintel, trimmer or jack stud, your rough sill, your cripple sill, sole plate, or your bottom plate. I call it a bottom plate. There's always going to be differences. Here we've got a good example of a door. A door, you're not going to have any cripplers. You're going to frame your whole wall with that plate still on for the door, and then later on you go around and you cut them all out with a Sawzall. It's a whole lot easier to build a wall. You can imagine building a wall if you put the opening in. There's nothing really holding the wall together. So you build it with that plate, raise your wall, and then you cut all that out later on. Sometimes you won't even cut out the openings for your doors or windows, depending on the job. Normally you do as much as you can when the wall's lying on the floor, right? Because it's a real pain in the ass once you raise your wall to deal with all this stuff. So you're going to put all your tie back, do all that, cut all your openings, and then raise your wall. Preferably you'll leave the tie back on because you're waterproof at that point. So that's the thing, is you'll deal with a lot of really high heat when you're working in the sun, because as you raise the walls, it cuts off all the wind, and you still have the tie back on the windows, so you're pretty much in a mini oven when you're working with your buddies. And some of the hottest days I've ever dealt with is framing in the sun when you're raising walls. If you're working on interior walls and your exterior walls are done, it gets hot, man. It gets hot. But you're kind of working with a t-shirt on at that point, door openings. Okay. We're good with that? Yeah? It's a good chunk of knowledge. Here's some more balloon framing. You can see again how it works there. There's his ribbon. I call it a ledger. It's notched into the stud, and the floor joists sit right on top. So it's a perfect view of balloon framing. Is my head in the way? And you can see how you get a full back going right through. Compared to us, we'd have that rim joist. All right. Here's a picture of that little T. It's called a wind brace. Right. That gets notched right into the stud work like that. You're gonna put that in on a diagonal. All the sheathing's off just so we can see stuff better. But here we go, corner stud, let-in bracing, cripple stud, rough sill. Another thing in Quebec, it's pretty much the norm now to put a little slope on your rough sill. When you cut those cripple studs, you're going to take off a few degrees and you're going to cut them all a little crooked, so that sill sits a little with a little bit of a slope. Okay, so that any water ever does get in there, it slopes out towards us. It's kind of new code. We'll do it down below. It's kind of a pain in the ass too, but the new style is to have that slope a little bit, right?
Yeah, what's his name?
Yeah,
He told me.
we already framed the wall. Yeah, extended it.
Yeah, for installation.
Guillaume, so you ready for the exam?
No.
Okay, second top plate. What do we do with the second top plate? When do we put that in?
Sorry?
The second top plate.
When you want to build this next floor.
No.
No, you do it when you are on the floor framing the wall, no?
I've only used
Because you know you're gonna need it.
What does the second top plate do?
I guess I assemble the walls.
The second top plate.
It's the bottom plate of the next wall. No.
No.
No, that's
It's the second topic.
More support.
no. It's
It's the top
it's
plate.
like it was the foundation of the second floor. No?
More support to join the other walls
The
together.
top plate, the top plate.
Join what?
The other walls. To join the other walls together.
You're gonna raise a wall. You're doing wall by wall, right? You're gonna raise a wall. This is the top plate of your first wall. Cool? You're gonna have a corner. You're gonna have studs. There's my wall. There's a bird's eye view of my wall. Right?
Yeah.
That's just one plate. There's a plate on the bottom, plate on the top. We'll talk about how we assemble a wall in a bit, but plate on the bottom, plate on the top. When you frame it on the floor, your bottom plate, your top plate, you raise your wall up. Right? That's done. Now what do? You build another wall. So you can have another wall going like this. Same sort of deal. Bird's eye view. Good. Now, when we're done, how do we lock in these walls? We have a joint, right? This is another wall that you've raised. You raise this wall, and then you build this one on the floor, and you raise this one like that. Now we have to lock in that corner. You're going to nail it, but it's still not strong enough. So the way we lock in that corner is with our second top plate. You're going to overlap. You're going to go right past the joint with your next plate. So you're going to measure from here, and your next plate is going to cover that whole joint, and you're going to nail that along there. And then your next one, your second top plate will go in like that. And it is a bit for support, okay? Because then you have a nice 3-inch chunk of wood, so if your truss does sit in between a joist space, it's not ideal, but that'll get transferred right down. You only have 16 inches, so like you're building your walls at 16 inch, and your trusses normally go in at 24 inch, so it normally doesn't line up. That ideal situation that I drew, that's in dreams, you know? So that's how you lock in your corners. Again, when you did what? When you did your floor, what's the last thing you do? When you pull out your little cord and your blocks of wood, do you remember doing all that? You did it in flooring. You did it with me in roofs, right? Before you start messing with your fascia, or you put your fascia on and you check it. Before you're done, you're gonna have to do all those adjustments, all that calculating, all that precise cutting we did. Even with the trusses, a nice engineered product, what did we have?
We need to eyeball it.
You need to eyeball it, you need to put a string on it. You're gonna do the same thing with a house. You're gonna build all these walls, everything's honky-dory. You've got a brace running down to the floor on a block of wood. You're gonna attach a string with a little block, a little piece of furring, a little 3/4 block. You guys remember doing this? You got another block over here, and you're gonna run a string nice and tight to make sure your wall is nice and straight. You have to do this before you put your second top plate on. You have to adjust all your walls. Your second top plate is kind of like solidifying everything. You can't really move after that.
Where do you put the blockings, the little blockings?
Well, you're just putting it on the outside.
On
You're
the
gonna run
outside.
around, you're gonna make sure your wall's straight. Like here it's so small, it's kind of silly. But you gotta think like a 50-foot long house, right?
Yeah.
You wanna make sure that wall's bang on, because what are you gonna put on top of the wall? You're gonna put trusses, right? So when we drop our trusses on, if our wall is going around like that, and we put all our trusses 10 inches off like that, what's our soffit gonna do? Right? So for that reason,